So in semester 4, in continuation with research methodology, we are going to learn another paper called QTBD, which is nothing but quantitative techniques in business development. It also consists of 5 units, and when compared to research methodology, here you are going to have more numerical problems. So each numerical problem will have a step-by-step procedure which will be discussed in theory. So it will have QTBD also has 5 units, where under unit 1 you are going to read the topics called ANOVA and SQC. These are the topics which you are going to read under unit 1. Under unit 2 you are going to read the non-parametric test. Unit 3 linear programming. It may not be the order. What are the topics? How many units means ANOVA, SQC is first 1 unit, and testing of independence of attributes is another unit, and linear programming problem is another unit, and you have NP tests and decision analysis. So these are the 4 units we are going to cover: ANOVA, SQC, testing of qualitative data which is called attributes, linear programming problem, non-parametric tests, and decision theory. These are the 5 units we are going to deal. Out of these 5 units, the first one, ANOVA, which consists of numerical problems and its corresponding theory. Similarly, SQC has procedure and problem. You may get problems from this, and also the theory. Mostly problems here you may get from this, and testing of independence also you'll have both problems and theory. LPP you'll get it also has, if you'll observe that all these units have majority problems only. Okay, so even though you get a theory question, that theory question is related to the problem only. If you can understand the problem clearly, you can write the you can write the theory or the steps involved in this. Today I am going to start with unit 1, which it has 2 parts called ANOVA and SQC. I am going to start with ANOVA. What do you mean by ANOVA? Means ANOVA is analysis of variance, is called simply ANOVA. Analysis of variance is called ANOVA. So what we are going to do under this is nothing but we are going to test the independence of more than 2 means whenever we have the case of testing more than the significance difference between more than 2 means, we are going to enter into a concept called ANOVA. This ANOVA was introduced by R.A. Fisher. So what does this? I'll take an example to understand this analysis of variance concept. Let us say that this is mainly related to agricultural experiment. Let us say that you are given a field, agriculture field, and it is divided into different plots. Field is an entire unit. The individual units of the field is called, each unit is called plot. Now you are with an agricultural field which is divided into small units called plots. Suppose that you are supposed to apply 5 fertilizers to each of these plots. You are given 5 fertilizers, and you need to apply to each or some of the plots in this agricultural field, and you need to find what is the difference or the significant effect of the different fertilizers on this field, which helps to give a better idea on each of these fertilizers. Again I repeat, there is an agricultural field, and here your question is nothing but you have 5 different fertilizers to choose the best one. Now here the question is nothing but which one to choose. So you need to check the mean effect of each of these fertilizers. So you should check the mean or average effect of each of these fertilizers on this plots or the field, and at the end, after performing this ANOVA, okay, the procedure which we are going to test the mean effects of these fertilizers is called analysis of variance. After performing this entire ANOVA, you are going to give a conclusion that which fertilizers gives a better effect than the other. So whenever the data or the field is classified with respect to only one factor, we call that as a one-way classification. Whenever it's divided with respect to two factors, we call that as a two-way analysis of variance. So ANOVA is of two types, which is called one-way classification and two-way classification of data. So whenever the entire field is or agricultural field or given experimental field is divided with respect to only one factor, we call that as a one-way classified data. So let us say that then the mathematical representation of such one-way classified data will be, it consists of only rows, means we write that as class, okay, sample observations. Means let us say that we have k classes under comparison. If you compare with the previous one, we have an agricultural field and we have k different fertilizers to apply, and we are writing each observation in this way: x11, x12, so on, x1n1, x21. This is mathematical representation of the field with respect to, or the experimental area with respect to only one factor. Here the factor here is nothing but class. Okay, whenever a table is given to you in this way with only one factor, how many factors are there? We have a factor called only class, means each observation here we are indicating with in general xij, where xij stands for the jth observation receiving the ith factor. Okay, this is called jth observation receiving ith factor is denoted by xij. So this is called the one-way classification of the data. What you under one-way classification, as you have k factors under comparison, you need to compare the mean effects of each of these k factors using one-way classification of analysis of the data, and at last you should come to a decision, or you should conclude that which factor is more effective when compared to this. So for this the ANOVA consists of the calculation part of this consists of a step-by-step procedure. Let us see that what are those steps for this. So we are going to frame in the step 1, we are going to write the H0, which is called the null hypothesis. Hypothesis is nothing but a simple statement regarding the experiment. What is the experiment here? You are given k different factors or k different fertilizers here. Now initially you need to write the null hypothesis. How many factors are there? K factors are there. So H0 will be null hypothesis. You should take always that mean we write with mu. As we have k factors, we write the mean of the first factor as mu1, mean of the second factor as mu2, mean of the kth factor as mu k. So under step 1 you should write the null hypothesis. The null hypothesis always is that the mean effects of all the factors is same. So if you consider the same example called, we have considered an agricultural field and you are applying, say 5 different fertilizers are applied to you. Before we conclude regarding this, we are going to frame a statement regarding the experiment which is neutral in nature, means we are not partial to any of those fertilizers. We say that the mean effects of all the fertilizers are same. That is, mean we indicate with mu. So we write, if there are 5 fertilizers, we will write mu1 is equal to mu2 is equal to mu5. It is a generalized case with k factors. So we write the null hypothesis as the mean effects of all the k factors are same. That is H0 such that mu1, mu2, mu k are equal. After writing the null hypothesis, you should write the H1, which is called the alternative hypothesis. Alternative hypothesis is always opposite to the null hypothesis. If you write all the mean effects are same, the null hypothesis will be the mean effects of different factors under comparisons are not same. So at last, after performing the ANOVA, analysis of variance, either you may say that H0 may be true or H1, but not both. So under ANOVA for one-way classification with single factor, what is the first step? You should write the null hypothesis. This is the way of writing null hypothesis and alternative hypothesis. So at last, after doing all the analysis steps, either you may accept this or you may accept. Sometimes after doing all the calculations, you may say that H0 is true, that is the mean effects of all the treatments or factors same, or H1 that the mean effects of all the treatments are not same. So this is step 1 is nothing but framing the hypothesis. After step 1, so we are going to we are focusing on the calculation part. What is step 2 means? You should calculate the grand total of the observations. Grand total, which we indicate with G. So step 3 is nothing but you should calculate correction factor, which we indicate with CF, which is given by G square by N. N stands for the total number of observations. Anyway, you'll understand in a better way when we are dealing with a numerical problem. So then you should calculate correction factor, and step 4 you should calculate raw sum of squares, which is nothing but, I'll tell you all this, and step 5 is nothing but total sum of squares, which is nothing but RSS minus CF. Step 6 you should calculate TI, treatment sums, and step 7 you should calculate SST, treatment, which is nothing but sigma TI square by NI minus CF. Okay, then step 8 you should calculate error sum of squares, which is nothing but total sum of squares minus SSTR, treatment sum of squares. Then in step 9 we are going to calculate F, which is called the test statistic. We call this as test statistic, which is nothing but the ratio of error sum of square, treatment sum of squares by error sum of squares. After calculating this, you should compare this F statistic with table value. Okay, whenever this F statistic value is less than table value, we accept H0. Whenever this is greater than table value, we reject H0. So you may I think this may be a little bit confusing to you. So if you enter into the numerical problem, what you need to do is nothing but you should practice a numerical problem. After practicing the numerical problem, then look into this procedure. Then this makes you then you can write whether the question is a numerical or a theory one, you can write easily. Just I want to go for a numerical problem on this. Okay. So here it is given that you are given question different textbooks like A, B, C, D, and scores obtained here. 68. So a professor wishes to select a good textbook from 4 different textbooks available. He has 37 students whom he distributes at random into 4 groups of 9, 10, 11, 7 students, assigning the books at random. After the course is over, all the students take the same test, obtaining the scores given below. Now you should examine if any of 4 books is to be preferred over the other. So it is given that a professor is given with 4 textbooks, and the question is nothing but after assigning or after distributing each of these textbooks to different groups, out of the 37 students are there, he divided the 37 students into 4 groups of 9, 11 and 10, 11 and 7 groups each, and he gave at random, he gave 7 A, B, C, D 4 types of the books to each of these groups. And after the test is over, he observed the scores obtained as below. Now you need to analyze the above data to examine which book is preferred out of these 4. So for this, the question will be clearly given to you, like carry one-way analysis of data. Okay, one-way analysis of data means you know that the data is classified only with respect to one factor. What is the factor here? Kind of the textbooks or the different types of the textbooks is the factor here. So it's clear that the question will be given like analyze using one-way analysis or carry out one-way analysis of the data. So what is the first step in the analysis of the data? As I said you that the first step in the analysis of data is nothing but you should set up a null hypothesis. What is a null hypothesis? We indicate null hypothesis with H0. How many textbooks are there? What are the factors here? Types of textbooks is the factor here. So as you have 4 types of textbooks, we write that the mean effects, means we write with mu, are equal. That is the mean effects of, or simply the effects of all the textbooks are same. So immediately after writing H0, you should write the alternative hypothesis which is rival to the null hypothesis. Means if you write the mean effects of all the textbooks are same, H1 will be the mean effects of all the textbooks are not same. So after writing H0 and H1, you should go for calculation process. So for that, arrange the data in a systematic way. So on the left side of the table, try to write the factor. What is the factor here? The factor here is nothing but the type of the textbook. How many types of the textbooks we have? 4 types of textbooks. So write the factor here. After writing that, so against A, I think in the question you are given with 9 observations. So list out all the 9 observations here. So I am rewriting the question here. So we are rearranging the data against each factor. Okay. Here no observations, some observations are always you'll have, there is no rule that you should have equal number of observations on each factor, on each category of the factor. So what you need to do, you need to arrange the data. In step 2, okay, you need to calculate the grand total, G grand total. Before that, let us write the total number of observations. What are the total number of observations here? Total number of observations here is 37. And also, you find out the number of observations in each row. How many and let it be n1. So in the first row we have 9 observations. In second row we have 10 observations and 11. And in fourth row we have 7 observations. Identify all these. And also we use K for the number of, K we use for number of factor, number of treatments. We use the word called number of treatments. Treatments means types of the textbooks we are using, which is nothing but 4. So in the usual notation, identify what are the total number of observations n, n1, n2, n3, n4 and k. Now you find out, step 2 consists of calculating G, which is called the grand total. Okay, grand total means you should add all these observations starting from 68 to the last observation 66. Here it is nothing but I have added all those, which is nothing but 21636. Add all those observations, and after this you should calculate step 2 after correction factor. CF is nothing but G square by n, which is nothing but 2136 by what is n? 37 observations. 1, 2, 3, 3. I have already done this, so I am writing those values directly. Step 3 is correction factor. Then step 4, what you need to calculate is nothing but raw sum of squares, which is nothing but you need to square each observation. Means start sigma, double sigma, xij square. Means 68 square. You need to square each observation and add all those. 68 square, 68 square, 69 square, 60 square till 66 square. Each number you should square and add each number, which I got this as raw sum of squares, which I got as 127598. This is step 4, which is called the raw sum of squares. After raw sum of squares, then you should calculate the treatments. Total sum of square you should go for. Total sum of squares. Total sum of squares is nothing but raw sum of squares minus correction factor, which is nothing but 127598 minus 123310.70, which I got as the total sum of squares as. So and step by total sum of squares, I got this as 4287.30. Next step involves calculating Ti square, which is nothing but Ti square. You need to add each row. Okay, find out the row totals. Means right here called Ti, which is nothing but sum of each row 68 to 75, which is nothing but 615. Similarly, add the second row, which is nothing but 522, 596 and 403. Means for in the next step you need to calculate the each row totals. So we have calculated thus. Then to calculate the treatment sum of squares, first of all you should calculate Ti square. Means T1 square plus T2 square plus how many we have? 4 rows, no? T4 square. Means first row we got 615 square plus 522 square plus 596 square plus 403 square, which is nothing but sigma Ti square is nothing but sigma Ti square. You should find out all those, and sigma Ti square by Ni you should do. Means you should calculate sigma Ti square by how many observations are there in the first row? We have 9 observations. In the second row we have 10 observations. In the third row we have 11 observations. And In the last row we have 7 observations. You should square that and 7. This total is we will calculate this total. Then to calculate the treatment sum of squares, which we write as SSTR square, which is nothing but the total of this minus correction factor, which is nothing but 1456.3. Already we have done CF and I didn't simplify this. You square by 9. I think you will get a value here. This minus CF is going to give you the treatment sum of squares, which we indicate with SSTR squares. And in the previous one we have calculated total sum of squares. How much we got total sum of squares? Here 4287.30. So to calculate the F statistic, you should calculate error sum of squares, which we indicate with SSE. SSE is nothing but total sum of squares minus treatment sum. This is the formula for error sum of squares. How much we got total sum of squares? 4287.30 minus 1456.30. So error sum of squares is nothing but total minus error sum of squares. Total we got 4287 minus 1456.34. This represents the error sum of squares. We have calculated error sum of squares. Then in the next step you are going to calculate the F statistic. What is the formula for F statistic? Is SSE by SSTR by SSE you should calculate, which is nothing but, what is SSTR? SSTR is nothing but treatment sum of square. How much we got? Which is nothing but 1456 by, and how much this error sum of squares we got? 2830.96. So here you should divide with how many treatments are there? We are indicating treatment with K, so you should subtract that, divide with K minus 1, error with N minus K. So this K is nothing but 4 minus 1, 37 minus 4. So we will get this as 485.45 by 85.78, which is nothing but 5.66. We have calculated F statistic. Then to accept or reject the null hypothesis, you should obtain the table value. Table values will be given for you in the examination itself. So here the table values given is nothing but F3,33 is 3.29. These values will be given to you. So after calculating this F statistic, you compare F statistic with table value. What is F statistic here? 5.66. You compare that with 3.29. I think 5.66 is greater than 3.99. So we are going to reject H0. So what is H0? If you reject H0, obviously you are going to accept H1. What is H0 here? H0 we wrote the mean effects of all the textbooks are same. So as you are rejecting means H0 is not true. What is then? Obviously you should go for H1. What is H1? The mean effects of the textbooks are not same. So we are, after doing all these analysis, you are going to conclude that the mean effects of the textbooks are not same. Okay, thank you.